I just want to cover functions. So all the code that we've done so far and the things that we've used to manage our program flow, we've done branching, conditionals, if, else if, we choose which sections of our code to execute, and we've done looping, which says take a section of code and run it potentially over and over again. Functions are a way to break up a section of your code into a functional unit that's hopefully just dependent upon one or two variables and be able to call it repeatedly. It's useful mainly as a management technique and also to avoid duplication. And pretty much all modern programming languages are structured programming languages, meaning functions play a large role in them. So let's look at the syntax for defining functions. And just note, you've been using functions all this time. Calling functions is a matter of adding parentheses after a variable. If that variable is a callable, then it will be called. So when we say list and add parentheses, list is a variable that points to an object of type list. And when we add parentheses, it actually calls that object, which means execute a certain amount of code, and that function returns a blank list in this case. We can define our own functions with the keyword def, short for define. We can give them a name. A name is a valid variable name, and I haven't mentioned that either, but valid variable names are alphanumeric, starting with an alpha and lowercase. So one foo is not a valid variable name, but foo1 is. We use parentheses to specify an optional argument list. A semicolon says this is a multi-line statement, and underneath is, in an indented line, the body of the function. And let's just print 1 right now. And I hit enter after unindenting, and nothing happens. There's no output. So I've created a function. I haven't called it. What it did, I've got a lot of stuff. Is add a variable called foo to my local namespace that is a function, and if I append parentheses to it, it'll actually call it and run the function body, which prints 1. Everybody with me so far? I can make multi-line functions. If I can figure out how my indentation works here. Print 1 and 2. And then functions should be able to accept arguments. When I'm inside of a function, what data do I have access to? Nothing, by default. So isn't that interesting? When I type locals right now, I get a big long list of all sorts of stuff that I've defined and a bunch of stuff IPython has made. And when I call my function and it prints out locals, there's nothing in locals. So a key Python concept is namespaces. And namespaces are created by a variety of things, including functions. But local to that function body is nothing. I didn't create any variables inside of it. It was able to call the function local, because local is in globals. It's a built-in. So my function foo can still access variables that are in the global namespace, but it doesn't have any access to the surrounding local variables by default. So if I want it to operate on something, I need to pass it in, and we pass parameters or arguments to a function just by specifying them by name. And it's a comma-separated list. They have limited access to globals. There's a couple ways of specifying what their access to globals looks like, and we'll get into the rules for how the namespace functions exactly in a little bit. The main thing from that is just to note that they don't have access by default to locals. Exactly. There's slight complications in how they access globals, but we'll talk about that in a second. So I defined a function that just prints out a first name and last name that I passed in. I can pass different variables to it, and this should give you an idea of what you might do to refactor your existing classmates program. If you've got lots of lines that do a print statement and kind of prettify it, and you've got that same line like 4 different places, you could define a function that prints a row from your classmates dictionary the way you want it, and then just call that function the 4 different places. And that means if you change it, let's say you decide that you want to make sure that the first character of a name is uppercased, you've only got one place to change it inside the function. You don't have to go to the 4 different places where you had the line before. So even though in that case it didn't save you any lines of code, you've reduced your repetition. And one of the primary rules of good programming hygiene is don't repeat yourself dry. We talked about docstrings earlier and said the first thing in a Python script could be a triple quoted line, and you'd actually have programmatic access to that. The first thing inside of any namespace can be a triple quoted line. So I've defined a function foo. It prints 1. You don't see that docstring thing in the output anywhere. But if I do help on foo, there's the docstring. So it is considered good Python convention to docstring everything by default. And if anybody is ever using your code as a library from the command line, they can at least glean something useful, hopefully something useful, from your short description. It's also kind of convention to supply docstrings where the first line is a short description, and then any tests or lengthy descriptions are separated by a blank from the rest. And several documentation generation libraries people use will give you the option of seeing just the first line or seeing all the rest. So let's go back to the classmates file and try out just a couple of these things. Is there anything else? Actually, you know what? I take it back. Let me go just a little bit further down the path of functions. Our zip function that we played with, what do you think the definition line for zip looks like? Since zip, how many arguments can zip take? We didn't really say, right? It takes lists. It works. It's giving me columns. And I can keep on adding lines, additional parameters indefinitely. Python has really sophisticated argument handling capabilities, so you don't have to do something like this and accept a bunch of different parameters. So I've got a special function declaration, foo and then starargs. And inside the body, I'm just going to print args. Notice no matter how many parameters I'm passing to it, it's able to accept them, and it's assigning them to a tuple of all the input arguments. And this is probably what the declaration of a zip looks like. So 2 ways of defining input parameters. One, we can give a position separated list of names. And 2, we can say, I don't really know how many parameters I'm going to get, but I want a list of them. Make sense to everybody? So the one new piece of syntax is star, and you could actually call args anything you want. It's just a variable declaration. The key piece of syntax is star. Okay? You should only use starargs when you know for sure that you take a variable number of parameters. So a function like zip is a perfect candidate for that. It takes some number of arguments and doesn't know how many. But most functions already know what pieces of data they're going to get. If you write a function that does a mathematical operation, like multiply, it takes 2 objects. So it already knows. So by default, you probably won't use starargs when declaring your functions. You will usually not. Just for special cases, you will usually not. No, just to be explicit. If you know that you accept 2 arguments, you should give them good names, and they should be part of your function definition, because I can introspect your function and say your function accepts 2 variables whose name are first name and last name, and I can probably figure out how to use your function. But if you have a function name with just starargs, that doesn't necessarily tell me anything. And we prefer cleanness at all times if possible in terms of our code. We write for ourselves and for other programmers more than we write for the computer. Okay, so 2 methods of function parameter declaration. Let's throw one more in there. Sorry, Danny. So the additional piece of syntax I've added now is the equal sign and a value. So I have a function definition. We got def, which declares I'm in a function. Foo is the name. Parentheses, I've got a parameter list. The first parameter looks normal. First name and a comma. It's a positional argument. The second argument, last name equals Franklin, is also the name of a parameter, but I go ahead and give it a default value. And that default value means it's optional. If I supply a value, it'll override the default. If I don't supply a value, the default will get taken. So the usage makes sense to people? And this is a way to write fairly flexible functions. You might have a function that will take optionally 3 or 4 pieces of information, and you might provide sensible defaults. Say something that formats text. You might typically want to format text. We were looking at the pretty print before. You might typically want to format text to fit within 80 columns. You could expose 80 columns as a parameter with a default value, and if it's not specified, it'll work the way you hard-coded it, and you offer the user a chance to override if they want to in a pretty trivial fashion. Okay, one more piece of funky syntax. Okay, the new piece of syntax here is star star. I did starargs before. Star star. Starargs was what? Star was a list, well, is a tuple of all the positional arguments, potentially unlimited number. Star star is a dict of all the name-based arguments, and those are arguments to which you have given a default value. So this doesn't work. And that does. So just like we can define default values when we define functions, we can also specify names when we call functions. They're slightly orthogonal concepts. So this function isn't specifying a default value. This function is saying I'm going to get a bunch of keyword-oriented names, not positional arguments, but arguments that are named. And you note they're not positional. I can reverse the order of these arguments. And it's going to get a dict of all the name-based arguments. When we've been calling functions so far, we've just been passing values. Not names, values. Yep. So a really common thing in functions is you've got a big complicated function and it's got like 7 parameters, and you really only ever need to supply 2. And if you do it positionally based, you have to supply all 7 to get the last one, the one time you want to use it. So you have to pass a bunch of, nils or falses or zeros to initialize all the other arguments and get to that last one. Keyword arguments take away the positional stuff and say, pass me function arguments by name. And I can combine our 2 new pieces of syntax, starargs and star star keyword args, for kind of the ultimate in flexible functions. And I have here a function that accepts some positional arguments, however many there are, and some keyword arguments, however many there are. And it's just printing off both in this case. The one limitation in terms of calling is all your positional arguments must precede all your name-based arguments. And obviously because the positional arguments are dependent upon position. And in this case, either one is optional. I could call it with none. Did I lose you, Yum?
One is the first one is the position, second one is name-based.
Yes.
So can you do the position, name? Can you sort it out, or
You can do position, name, but you can't do any more positions after that.
Oh, you cannot do
Positional arguments have to come first, then name-based arguments. And our star args and star star keyword args are only letting us accept an unlimited number of these. I could mix and match positional and name-based arguments explicitly by saying first name, and that's a positional argument because I'm not giving it any default value. That's a name-based argument because I am giving it a default value. Def. right? That's kind of what we were doing before. All starargs and star keyword args does is let me accept an unlimited number of them. And in the function definition, as well as in calling, all the positional arguments have to come first, all the name-based arguments have to come afterwards. Okay, you confused yet? There's one more additional piece of complexity on calling, but I don't think I'll talk about that additional piece of complexity till tomorrow. For now, let's go back to our classmates lab and let's do a little bit of refactoring. Question?
The pattern is able to distinguish the position-based input versus the name-based input by looking at the way you
Initialize the function, yes.
function. So if I don't initialize it, it will be taken as the positional-based argument. Is that right?
If you don't initialize it, they're positional arguments. If there's no equal sign, it's a positional argument.
Okay.
Yep.
So that would be the way to remember that one. Okay.
And by default, you'll typically write functions that take just a couple arguments and they're positional arguments, right? That's how most of the code you've written in other languages works.
But in early example you showed, for the positional, the argument, you also can initialize some value, right?
Nope. If I initialize it, then it's automatically a keyword-based value.
Keyword-based
it can be the
value.
first one.
Okay. I see what you're saying. Okay, so you mean your early examples. So anytime you initialize it.
If you initialize it, it's keyword-based, and it's also optional. And that's the other funky thing is, since you've given it a default value, you can call the function without supplying that value. And if you want a keyword-based argument that's mandatory, you need to initialize it to something like none or false, check for that value in your function, and raise an exception if they're
it's clear.
Okay, so we have regular arguments. They're positional. We give them names in our function definition, but we only use those names internally to the function. And outside the function, we don't see those names. We pass just values, plain old values. And then we have name-based optional arguments. And outside the function, we specify that we're getting a name-based parameter by saying name equals value when we call the function. And inside the function, that value did not have to be supplied when the function was called. So it's always set, whether it was supplied or not. It's got a default argument. Okay, first and most simple refactoring. Refactoring, by the way, it's a great book. One more question.
One more question. The name that you're using here, like a last name, as part of the input parameters, those will be treated as the locals to the function.
They would be, yes.
They will not be treated as the locals at the higher level hierarchy.
Correct.
So you're not going to be able to see that one, right?
So outside of the function body, if I say last name, it doesn't exist.
Doesn't exist.
It's local to the function namespace. That's correct. So let's do our first and most easy refactoring. Let's go ahead and open your classmates file, save it as a new classmates.3, classmates3.py file. And let's think about what sorts of things we could move into a function. One of the things, refactoring, by the way, it's a great book. It's written about Java. But it's basically the art of rewriting your program that's already working for the purpose of making it more maintainable, which usually translates to easier to understand and easier to change. And it's got bunches of examples and rules for rewriting things. My own personal rules, chief among them is less code. The less code I have to read in an algorithm, the easier it is for me to understand it. If you give me a loop that's 2 pages of printed code, the chances that I actually understand everything that loop does is really close to nil. It's just too much code to comprehend. If you give me a loop that has 4 lines as the body of the loop, even if those 4 lines are calling functions, I at least have a really good conceptual understanding of the loop. And I can probably test the functions a lot better because they're not part of the loop. They can be tested kind of standalone. So let's remove some code from our classmates loop and put it into functions. And particularly, I'd like to remove code that gets repeated. So you probably are printing out a record a few places. Let's define a function called display record. And let's pass it our tuple. And let's have it print our nice, name, first name, last name is a role. And maybe another candidate for refactoring would be our input. You have several lines of input. where you prompt the user for a first name and last name, and out of that you get a couple of variables. Let's refactor that to a function called newRecord, and that requires one last piece of syntax that I should have mentioned with functions. Functions do things, they run the body, so we've been calling our function foo here as we repeatedly define it, and it does stuff, but does it return anything? It said x is equal to foo, and x is equal to nothing right now. So functions by default return none, but there is a language keyword return. Which return stops the execution of the function when it executes, no matter where it is in the function. If return was the first statement of my function, the rest of my function body would not ever run. And now when I run foo, I can see that it's got output. Here is the return value. And it also printed 1, and I can say x is equal to foo. And x now has a value. So we could write a function that solicits input from the user and returns a first name, last name, role tuple. And in fact, I'd like to do just that. Refactor. Yes, there are. You can't use any keywords. And keywords, I thought there was a built-in module. Keyword. Keyword.kwlist has all the built-in keywords. So we've seen a bunch of these, like if, for, while. There's break and continue. So you'll get a syntax error if you're trying to use one of these. Then the built-ins you can actually overwrite if you want to. Like stir is a built-in, but I can go ahead and type my own function called stir. But just because you can doesn't make it a good idea, and is extremely likely to break your code. So it's worthwhile knowing the built-ins and not overriding them if possible. Yes, there are. You can't use any keywords. And keywords, I thought there was a built-in module. Keyword.kwlist has all the built-in keywords. So we've seen a bunch of these, like if, for, while. There's break and continue. So you'll get a syntax error if you're trying to use one of these. Then the built-ins you can actually overwrite if you want to. Like stir is a built-in, but I can go ahead and type my own function called stir. But just because you can doesn't make it a good idea, and is extremely likely to break your code. So it's worthwhile knowing the built-ins and not overriding them if possible. Everybody's industriously typing away, and our like official lecture portion is over. But would anybody? It seems like everybody's hitting the material pretty well. Is anybody feeling lost? Do I need to pay attention to anybody? Everybody feels okay. Okay, so our classmates program by day 4 is going to read and write from a text file using the CSV module. So you could look at it with an Excel spreadsheet, and so that your inputs and outputs are saved between program runs. We'd like to present a quick menu, which will, I think I have 7 options on the final thing, which lets the user choose what sort of option they want to take initially. And for the moment, I just like to go ahead and add the menu, and not all the functionality has to work. But the functionality that we're interested in is what we have already, print everything out. We like to search by name. We also like to do some other filtering things like filter by role. So show me only the teachers or show me only the instructors. We'd like to add a record. But basically, the main loop of your program is going to switch from just soliciting a name to presenting a menu and executing a particular function, probably based on what menu item was selected. We'll talk tomorrow about how best to structure your program. There's a couple of Python idioms when you start progressing beyond scripts into actual programs. Probably by tomorrow, we'll be pulling your program out into a package and module system as well, so not all of your code is living in a single file. And optionally, at the end, depending on how enthusiastic people are feeling, we may try talking to a database instead of talking to a text file. And we're going to be spending parts of the third day and fourth day on object-oriented programming, some of the benefits of which are code reuse and some of which are just fluency. And we'll see the benefits of refactoring our program to use objects instead of relatively dumb data structures like tuples or lists for our records. That's kind of where we're going in terms of our labs. And then we've got a few other topics to cover along the way. Doc tests are probably going to sneak in tomorrow. Unit tests, which is another testing library, will sneak in on the third day. And tomorrow basically we're going to finish off with functions, kind of reiterate some of the stuff that we talked about at the end of today, and just one or two extra tweaks. Error recovery with exceptions, and code organization, and we'll be tweaking the classmates to read and write and search through files instead of just from a static data definition.